Okay, peeps, today we're doing fractions, decimals, and one-step equations. And this is a review. You've learned this all previous to being in 8th grade, so this should go quick for us. First of all, when we add fractions, let's say we have 3/8 plus 7/4. We know that we cannot just go ahead and add the fractions with unlike denominators. We need to make sure that both of our denominators, the 8 here and the 4 here, are the same. That's our denominator, and that's our denominator. Think denominator down, because it's on the bottom. So, in order to get the same denominators, we need to find the least common multiple of both the 8 and the 4. So, an easy way to do this is to just go ahead and list the multiples of each one. The multiples of 8 are 8, 16, 24, 32, 40, and they can go on forever, but we'll stop there. And for 4, we have 4, 8, 12, 16, 20, 24. Okay. And our least common multiples that match are going to be the 8 and the 8. So now we know that we need to make both of our denominators 8. Well, this one's already 8, so I don't have to do anything to it. So I can just copy that, because that's going to stay 8. This, however, needs to change to 8. So how do I make that 8? Well, I can multiply it by 2. And what I do to the bottom, I do to the top. So, if I multiply 4 times 2, I get 8. And if I multiply 7 times 2, I get 14. Now my denominators are both 8. They're the same. So that means that I can go ahead and add my numerators. So, 3 plus 14 is 17, and our denominator stays the same when we're adding, so we have 17/8. Now, in 8th grade, we do allow you to keep your fractions in improper form. You do not need to change that, and you cannot reduce it any further because there's nothing that goes into both 17 and 8, so you can leave it just like that. Now, for subtracting, we do it very similar. Let's say we have 9/8 minus 2/3. We need to first make sure that our denominators are the same, and they're not. So we can go down here and list our multiples again so that we can find the least common multiple of both 3 and 8. So for 8, we've got 8, 16, 24, 32, 40. We'll go ahead and stop there. And for 3, we have 3, 6, 9, 12, 15, and you'll see that I'm just counting by 3s, 18, 21, 24, oh, I found one. 24 seems to be our least common multiple for both 8 and 3. So I need to make these both 24. Well, how do I make the 8 24? Well, I can multiply it by 3. And what I do to the bottom, I do to the top. So this first one is going to be 8 times 3 is 24, and 9 times 3, which is 27. Keep my operation. And how do I make the 3 24? Well, I can multiply it by 8. And what I do to the bottom, I do to the top. So 24 is going to be our denominator, and 8 times 2 is 16. And that's going to be our numerator. Now I can just subtract my numerators, because my denominators are finally the same. And 27 minus 16 equals 11. And our denominator stays the same, so we've got 11 over 24. And that cannot be reduced any further because nothing goes into both 11 and 24. So it's going to say 11/24. Next we have multiplying fractions. Multiplying fractions are my favorite because they are the easiest. I do not need to worry about having a common denominator. All I really have to do is multiply across. So when I see the multiplication, I can just say, well, 2 times 5 is 10, and 5 times 6 is 30, and there you go. Now, this one does need to be reduced, so I can see what goes into both 10 and 30. Well, if I wanted to do this, I could do this. I could list all of the factors. So 1 and 10, because 1 times 10 equals 10, and 2 and 5, because 2 times 5 equals 10, and that's about it. And then for 30, I've got 1 times 30 equals 30, and 2 times 15 equals 30, and 3 times 10 equals 30, and also I've got 5 times 6 equals 30. Now we want our greatest common factor here to reduce it as quickly as possible, and that happens to be the tens. So 10 divided by 10 is going to be 1, and 30 divided by 10 is going to be 3. Now, if I didn't want to do all this and I couldn't remember that 10 goes into both, I could have just said, well, they're both even numbers, so I could have divided both of them by 2, and I could have started there. And 10 divided by 2 is 5, and 30 divided by 2 is 15, and that's a little easier to work with. I know that 5 goes into 15, so I can divide them both by 5 to reduce it even further. And 5 goes into 5 one time, and 5 goes into 15 3 times, which gives me the same answer. But to make it easiest, of course, you always want to do the greatest common factor. Okay. Now we have dividing fractions. So for dividing fractions, let's say our example is 4/7 divided by 2/3. I have this fabulous rule that I know you all have heard before. It's called keep, where we keep that one. Change. We're going to change the operation, and flip. Keep, change, flip. We're going to flip the second fraction. So we keep the first fraction, which is this one. Oops. So that's going to stay 4/7. We change our operation to the opposite, which is multiplication. And then we flip the second fraction. So we've got, oops, I forgot to flip. So we've got 3 halves, because I flipped these over right here. So now we are back to multiplying, and they're very easy. So we just go across. 4 times 3 is 12. And 7 times 2 is 14. And that can be reduced because I know that 2 goes into both of them. So 12 divided by 2 is 6. And 14 divided by 2 is 7. Okay, so key change flip when we're dividing. Next up, we have adding and subtracting decimals. So when we add and subtract decimals, we just need to make sure that our decimal points line up. So if I have 6.3 plus 2.456, I can add those together by just making sure that I line up my decimal points. So 6.3, let's write it another way. And here's my decimal point, so I'm going to line that up right there. And I have a 2 on the left of it, and I have 4, 5, 6 on the right. And I can add that. Here, there's nothing here, so I'm just going to put zeros as placeholders. And then I can add 0 plus 6 is 6. 0 plus 5 is 5. 3 plus 4 is 7. Keep my decimal because my decimal goes straight down. And 6 plus 2 is 8. So you want to remember to always line up your decimals. That is so super important. Okay, let's try one that is subtracting decimals. Just practice that one. So I have 9.99 minus 6.431. Again, same as adding, I just had to make sure my decimals are lined up. So let me go ahead and write my first one. I have 9.99, and I'm going to subtract. Got to line up my decimal, so here's my decimal. And I have a 6 on the left, so I'll put my 6 in, and then I have 4, 3, 2, 1 on the right. So 4, 3, 2, 1. And again, I've got this empty space up here, so I have to add zeros for place keepers. And now I'm subtracting, so I can't do that. I've got to borrow from all the way over here. So borrow from him, give it to him, but then we need to borrow again. Okay, so now 10 minus 1 is 9, and 9 minus 2 is 7, and 8 minus 3 is 5, and 9 minus 4 is 5. Keep my decimals in the same place, so I just bring it straight down. And 9 minus 6 is 3. So my answer here is going to be 3.5579. Okay? Next, we have multiplying decimals. So if I multiply 2.34 times 4.56, again, multiplying is our friend here because we don't need to line up our decimals. We can just go ahead and multiply it. So 2.34 times 4.56. And I can just multiply. 6 times 4 is 24. Carry the 2. 6 times 3 is 18. Plus 2 is 20. Carry the 2. 6 times 2 is 12. Plus 2 is 14. Put my 0 here to hold my place. 5 times 4 is 20. Carry the 2. There's already one there. 5 times 3 is 15. Plus 2 is 17. And I'm going to carry my 1. 5 times 2 is 10, plus 1 is 11. Okay, now I'm on this number, so I have to put 2 placeholders. And 4 times 4 is 16. Carry my 1. 4 times 3 is 12, plus 1 is 13. Carry my 1, there's already one there. 4 times 2 is 8, plus 1 is 9. Now I'm going to add all these crazy numbers together. 4 plus 0 plus 0 is 4. 0 plus 0 plus 0 is 0. 4 plus 7 plus 6 is 17. Carry my 1. 1 plus 1 plus 1 plus 3 is 6, and 1 plus 9 is 10. Now, where in the world does my decimal go? Because I don't need to line them up, but I do need to count. So how many places to get from here to the end of our number? We need to do that for both of these numbers here, where the decimal was, where we multiplied. So I'm going to count. 1, 2. I had 2 places here, and here I need to get it to the end again. Count again. 1, 2. I had 2 there. Now I have to combine them, so I have 4 decimal places. So 4 decimal places. That means that when I move down here, I need to go 4 decimal places in. So if you don't see a decimal, you know that it's always at the end. So here's my current decimal, but I have to move it 4 places. So I'm going to go 1, 2, 3, 4. And it's going to go right there. So my answer is going to be 10.6704. Okay, moving on. We are going to go ahead and divide decimals. So I have 2.1 divided by 4.2. So I need to do 2.1, we write it the way we say it, divided by 4.2. Now, we cannot have a decimal outside the house. So we need to move him. So we move him all the way over here to get rid of him, okay? But what I do on the outside, I have to do on the inside. So I moved him 1 space here. That means I need to move this guy 1 space here. And like in adding and subtracting, we keep our place with the decimal, so we're just going to bring him up. And he's going to go right there. Okay? Well, now I can go ahead and try to divide. So I've got 42 here, right? I have 42 because we moved our decimal. And I've got 21. How many times does 42 go into 21? 0. Doesn't go in at all. Oh no, I have nothing left. What do I do? I'm going to go ahead and add a 0 here on the other side of my decimal. Now I can say, how many times does 42 go into 210? Well, I think it's going to go in about 5 times. Okay, so let's check that out. Let's see if it works. 5 times 2 is 10. Carry the 1. And 5 times 4 is 20, plus the 1 is 21. And if I needed to do that off to the side, I could do 42 times 5 is 210. Perfect. Look at that. I don't even have to go any further because 210 minus 210 is 0, so I'm done. So my answer here is going to be 0.5. Okay? Just remember you have to move that decimal over, and whatever you do to the outside, you do to the inside. Fabulous. All right. Let's talk about one-step equations. So let's go with our first example. We have 3 plus x equals 9. So our main goal is to isolate the variable. So what is the variable? The variable is what we don't know, which is this guy here, x. He's standing for something else. We just don't know what it is he's in place of. So we need to find that out. And we need to get him all alone. So our very first step always is going to be to make our train tracks. Okay, and we're going to make them nice and long because eventually we're going to have lots of things to do here. Then our second step is going to be to move, to box and circle. Box and circle. Box and circle, box and circle. I'm going to box. I got a number here. I got another number here. And then I already circled my letter, which is my variable, so now I've got 2 boxes with numbers and 1 circle with a letter. So I can go ahead and do that.